Hi everyone, today I'm going to show you how to set up this rotation array with an offset for each diagonal. First I'm going to show you how to set this up kind of the quick and easy way, and then I'll show you how to make it entirely procedural. By the way, if you don't feel like setting all this up for yourself, you can grab an HDA of this on my Gumroad for a couple bucks. All you need to do is plug in your geometry and play with the settings, and it works. Okay, so let's get started by dropping down a geo as always, and in there we want a grid, we want a pig head, we want a copy to points. Let's plug those in. For the grid, I want to make it vertical and turn it around and make the big head a little bit smaller. Cool. So the way we're going to make the offset on the grid for the rotation is going to be to create a color that goes from 0 here to 1 here, and then we can just make an attribute from that and use it for the offset. So there's a nifty node called attribute adjust color, and in here you can set the pattern type to line. This allows you to create a line to get a gradient, which is pretty cool. So one way you can make this procedural is for the position of these points, you can use the bounding box function, which is pretty nifty. So 0 for the geometry and then, or surface node, and then, surface node, and then d underscore x min, because we want the minimum value on the x-axis for this one. And boom, now it sticks perfectly to our bounding box. We can repeat this for the other axes. 0 d underscore y max. You can see it's exactly in the corner where we want it. This one's going to be x max and then y min. Cool. Also, you want to make sure it is grayscale in here, because then the three components of the CD vector are the exact same. So let's drop down a wrangle in here and just create an attribute called rotation, which is going to be equal to @cd.x. And if we preview it, you can see we get a value that is the same for each diagonal, which is exactly what we want. So let's just hide this. And now what we want, actually I'm going to draw down a normal node and add normals to my points. And then a for each point. And in here, we're going to start by match sizing so that every point is in the center. And we also want to stash the transform because we're going to be restoring it later. So after that, let's add a transform. And you can see the normal here. This is where we're going to animate the actual rotation. So I'm just going to keyframe it really quick, like so. And we have our point turning. And if we want to see all the points, all we need to do is add a match size, untick this, and only restore the transform. So if you look at this, we've got all our points back in their original position, and they're all turning, but at the same time. So to introduce the offset, we're going to add a time shift node right in here. And in here, we want to do minus, and then fetch our rotation attribute that we created earlier. So the way you do that is point, and then brackets, and fetch the for each begin, close the brackets, then 0, then rotation is what I called it, which is the name of the attribute. Now if you look at the attribute, it goes from 0 to 1, just like the color does, which isn't going to make a big noticeable difference. So we need to multiply it by some amount to make it have more effect on the offset. So let's just do times 100. And now, if I make my normals bigger, so it's easier to see. I mean, that's kind of huge. We've got our offset. That's really pretty, actually. But yeah, you can see there's an offset according to each diagonal of our grid here. And so if you want less offset, you can just take this down to a smaller number like 10. Now they're almost all going to turn at the same time. And if you want a crazy amount of offset, just make it really big. And it's going to be a lot slower to kind of move through our grid here. Alright, pretty cool. And if we check it out with the pig head, let me just hide this and this and this. And also I forgot to clear the color right here, so it doesn't transfer the color to our objects. And there you go. So this is the basic setup, but what happens if you have a grid that isn't a square? Then it breaks, doesn't work anymore. As you can see, like these two pig heads are supposed to be rotating at the same time, and they are not. The reason being, this node right here, when we create our color line, if I just turn on the grid, if you imagine like perpendicular lines shooting out of this one, we want those perpendicular lines to be like at the same angle, to be crossing every diagonal, basically. We want them to have the same angle as this point to this point, which currently obviously it doesn't have. So how do we set this up so that it works no matter the ratio of your grid? Well, we want to create our own color line instead of using this node. So let's start off by dropping down a blast. And what we're going to do is isolate this primitive right here, and then isolate this point and this point, create a line between the two so that we can then rotate it to get a perpendicular line, which we are going to scale out from here. And next, what we want to do is the angle of the diagonals through the grid. We want to keep that same angle and create a line that starts from the bottom right here. So we're going to have a line like this and another line like this. And we want to, at that intersection, cut this first line and then kind of extrude it out along its normal so that we can create a grid that has the correct orientation that we can then use to transfer the color onto our original grid here. So how do we do this? Start by blasting away prim number 0, keeping only that one. Next, another blast, and if we look at our point numbers here, we want point 1 and 2, so let's just do that. 1 to 2, make sure it's points. Now let's create a line between those two. There we go. Now let's transform it to turn it 9 degrees. Let me have this in the background. Let's move pivot to centroid and then turn it by 90 degrees. Now we want to snap it back to the corner here, which we can do with a match size. If we use our grid as a reference, just do min, max, there we go. Now with this right here, alright, so next, another transform node because we want to make this bigger, but obviously if we just do this, it doesn't work. We need to set our pivots to be in this corner right here, which again, you can use the bounding box trick. There we go. Let's make it really big, like 20. So next we want to create this line from the bottom right corner to have our intersection of the two lines. So I'm going to go back to this line before we turned it by 90 degrees. And let's match size it to the middle because we're gonna copy the point, which means it has to be centered. Whoops, do this. Now we want to isolate this point right here, and what you can do is just use an add node to create a single point, and then again match size it to be in the bottom right of our grid. So x is going to be max and y min. There we go, there's our point. And we can use this point to copy the points. So we got our line down here. Now let's transform it. Not that one. Move pivot to centroid. Let's make it really big. So we've got our two lines right here. Let's merge them and then use a intersection analysis. And that's going to create a single point where they intersect. Now we want to take this point and then take the original point and join them. So let's take this line, use a blast, and just keep point number 1. There we go. And then merge these 2 points and then add node to create a primitive between the two. There we go. So now we have our line with the correct angle, right? So if you shoot out perpendicular lines from this one, they're going to cross every diagonal point. And it also has the correct length, so that if you shoot out a perpendicular from point 1 here, it's going to meet exactly at the bottom right of our grid. So what we want to do now is essentially move it down here and then copy it and move it up here and then join the two to make a grid. But obviously we're going to keep this procedural. So how do you do that? Let's drop down an attribute wrangle. And actually before that we need to resample it, because we don't actually need more points, we just need the tangent attribute, so let's name it n. And then in our wrangle, let's actually look at our normals here, which you can see are going exactly in the direction and the length of our line. And we want them to be going perpendicular so that we can move it along that axis. So the way you do that is at n equals cross. So we want to do a cross product of two vectors, the first of which is going to be n, and the second of which is going to be like n inverted, like plus 180. So at n, plus 180. There we go. Yeah, exactly what we wanted. Our normals are now perpendicular. Now, why didn't I just do n plus 90? Because it doesn't work. All right, that's the best answer I can give you. So next, let's do at p plus equals at n, and it just disappeared because it's very far away now, but in the correct like direction. So I'm just going to do multiply by channel float. Let's call this amount. There we go. Let's create that parameter. Now we can, whoa, okay, that's still very strong. So let's divide that by 100. There we go. That's better. And what? Oh, as you can see, it's also moving in the z direction, which we don't want. So let's just do at p dot z equals 0. There we go. Cool. So I'm gonna maybe do like 10 for this one, and then copy this over, and let's do -10. And then, so it's up here now. Merge these two. And so how do you create a face, like a primitive between these two lines? The way you do that is with a NatSop, of course. Go to polygons, we're going to create a prim between point number 0 and 2, and another one between point number 1 and 3. So now we want to polyfill that in with just one big face, and then remesh it, because we do need somewhat dense geometry for the transfer later. Cool, but it's missing the color, so in our resample, let's add a curve view and then add a attribute adjust color again. And let's do remap attribute, select curve view, make it grayscale, and boom, now we have a nice gradient. All right, so what now? Let me take all of this and move it down. Whoops. Well, now we don't need this anymore, but we do need an attribute transfer. Our original grid is going to go in here, and this one goes in here. Whoops. And it, well, automatically transfers color. There we go. Now, if we plug this in here and look at the value of rotation now, what we're going to find is that every diagonal has almost the same value. Not quite. I don't know why, I'm going to be honest. I could not figure it out. But it's an easy fix, so I'm going to show you how to fix it. Alright, so to fix this, we want to round these values to the nearest value, so they're all the same. But if we do it now, you know, we're gonna get 0.05 and then 0.06, which isn't good. So I'm just gonna do times like 20, and now if we round, we're gonna get 1 and then 2 and then 3, right? So make it bigger, and then rotation equals our int, I believe. Yep, to round the number to the closest whole number, f at rotation. And boom, there you go. So diagonal 1 is 0, and then 1, and then 2, and then 3, and 4, and so on and so forth until 18, 19, 20. Now, there's actually something wrong here, because I just put down an arbitrary big number here, when what we need to do, well, look at this, 0, 1, 2, 3, 4, 5, 7. There's no 6, right? Because we need to actually multiply it by the number of unique diagonals. And the way you figure that out is you look at your number of rows and columns, add them together, and then subtract 2. So that's going to be 18. Here it is. So if we just do 18, there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth until 16, 17, 18. All right, and now I'm just gonna take my rotation attribute and fit it from, well, at rotation, fit it from 0 to 18 to 0 to 1. That way, if you change the number of rows and columns, you're always going to have the same offset between them, right? Because we're going to be using this value to multiply our offset. So if we check this out now, I believe we've done everything and it should work. Yes, sir. Look at that. So cool. And if I change it up, let's go like, I don't know, 7 by 4, and then let's have like 6 and 12. Whoa, what the fuck? Okay, what's going on here? This is where our problem lies. So we need to do the transform before the copy the points, not afterwards. That's my bad. Let's see. Just reset this. There we go. And now everything should work. Let's hide this. Yeah, there we go. All right, cool. it is in fact working as expected. Pretty cool, pretty cool. And yeah, again, if you don't want to go through the trouble setting all this up, you can just pick up the HDA I made. All you need to do is plug in your geometry, and then you've got settings for the rows and columns and the size of your grid. This right here is where you animate the rotation and then the offset. Yeah, and it's all procedural, it all just works. Just gotta plug in your geometry. Let's see. Just gonna show you how it kind of updates. Just like that, and then let's do like less offset. And boom. Oh, that's so cool. Alright, thank you guys for watching. I hope I could teach you something useful, and I'll see you guys next time. Bye bye.